Okay, in this video, we're going to work backwards. We are going to take expressions that are expanded and we are going to condense them. Now, when we were expanding expressions, we went through and used the quotient rule, then the product rule, and then we used the power rule to bring down any exponents down into the coefficient position. So when we're condensing, we're going to work backwards. So the first thing we're going to do is look to see if there's any coefficients that we should bring back up as exponents and work backwards. So in this first example, we do not have any coefficients in front of the logs that we need to bring up as exponents. So then the next step is to use the product and the quotient rule to condense multiple logs into one log. So doing this one step at a time, first I'm going to condense these two logs into one log. Because their bases are the same, I can do that. Now if the bases were different, I can't do that. I would have to just leave it as is. Just like if I asked you to add 2x plus 3y, you can't combine those together because they're not like terms. So the only way that you can condense logs is if they have the same base. So keep that in mind. So for log base b of 8 plus log base b of x, I'm going to condense those by using the product rule. I can change addition of two logs into one log with a product. So that would be 8 times x. And then I'll just carry down the next log. Okay, now I have these two that I can condense. So since their bases are the same, I can condense this using the product rule again. So I would have log base b, and I can take the 8x times the y and make it 8xy. And so now this is completely condensed. Okay, in the next example, I have a subtraction. So I know I'm going to be using the quotient rule. I don't have any coefficients in front of the logs that I would first need to pull up as exponents. So I can go directly to using the quotient rule. So I'm going to rewrite this as one log because my bases are the same even though it's not written in there. We know if it's not written in there, it's assumed to be base 10. So my bases are the same. And so I'm going to rewrite this as 33 over 11, which I can then simplify as log 3, because 33 over 11 is just 3. Now in the next example here, I do have a coefficient. I have a coefficient of -1. So the first thing I want to do is bring this -1 up as the exponent for the 1/6. So I'm going to rewrite this as natural log of 1/6 to the power of -1. And I can simplify that if I don't want a -1 exponent. When I take 1/6 and raise it to the first power, that gives me 1/6. And the negative exponent tells me to flip it upside down and take the reciprocal. So that would be, the reciprocal of 1/6 would just be 6. So my final answer would just be natural log of 6. Okay, in example 4, I don't have any coefficients in front that I need to bring up as an exponent. So the next thing I do is use the quotient and the product rule to combine multiple logs into one log. Since this is an addition problem, I'm going to use the product rule, and I'm going to make this one log. My bases are the same. It's natural log, so my base is e for both of them, so I can combine them. And I'm going to rewrite this as 5a to the 4th times 4a to the 5th. I'm going to multiply those two together. And then I can clean it up and simplify it by making that natural log of 20a to the 9th. In example 5, I don't have any coefficients in front that I need to bring up as an exponent using the power rule. And so then I'm going to go to the quotient or the product rule to simplify this. This is a minus, so I'm going to use the quotient rule. And since both are natural log, I have the same base, so I can combine these together. So I'm going to take the natural log and I'm going to write it as this 15s to the 8th divided by 5s to the 4th. And then I can simplify that because 15 over 5 is 3, and s to the 8th over s to the 4th is s to the 4th. Okay, in the last example, I do have exponents that I need to bring up in front. So I have the 3, I have 1/2, and I have a 3. All coefficients that I can bring up as exponents. So the first thing I want to do is rewrite this as log base b x to the 3rd, because I'm taking this 3 and bringing it up as the exponent. Same thing with this 1/2. I'm bringing it up as the exponent, and then I'm going to bring up the 3 as the exponent for the z. So that gives me minus log base b y to the 1/2 plus log base b z to the 3rd. Okay, so I brought up all my coefficients as exponents. Then I'm going to use my quotient in my product rule to combine my multiple logs. So let's look at this one first. I'm going to work left to right. This would be a subtraction, so I'm going to change this to a quotient. My bases are the same, they're both b, so I can combine them together into one. So I have log base b of x to the 3rd over y to the 1/2. And then I'll bring down the log base b of z to the 3rd. Now I have these two logs that I need to combine. That is being combined with addition, so when I combine it into one log, I'm going to use the product rule and change it to multiplication. So I have log base b of x to the 3rd over y to the 1/2 times z to the 3rd. Now to clean this up a little bit, if I want, x to the 3rd times z to the 3rd can go on top, because remember, this is over 1, and I multiply across the top and across the bottom. So I can rewrite that z to the 3rd on top. And then on the bottom, I would just have y to the 1/2. And if you would like to, you don't have to, but you can also rewrite that as the square root of y if you want to rewrite it using square roots. So this would be my final answer. Everything condensed.